All right, we're going to continue our discussion of the elimination method. But we run into a little difficulty here. Okay, we're trying to find a solution, trying to find out where these intersect using this mathematical method of calculating that intersection point. What I notice right off the bat is that neither of these equations, okay, are in a form, okay, where we can eliminate the x term or the y term. And in this case, we're actually going to have to not just modify one equation, we're going to have to modify both. Right? So what we need to think about is, what method are we going to use? Okay, we talked about this in the last video. What method are we going to use? Meaning, are we going to add them or subtract them? Okay. What variable are you trying to eliminate? Okay. So when I look here, 7 and 3. Okay. What I'm thinking of is what is the least common multiple of 7 and 3? Right? What number will 7 and 3 divide into evenly? Right? And what I notice is 21. Right? 7 will divide into 21 evenly, and 3 will divide into 21 evenly. All right? So now, if I want to eliminate the x terms, I'm going to want to get the top to be 21x and the bottom be 21x if I'm going to subtract. Okay? If I'm going to add the equations together to get rid of the x's, I would want one of these 21s to be negative, right? Positive 21, negative 21. All right? Okay. Let's say I'm trying to get rid of the y terms. I have a negative 5 and a negative 3. Well, guess what? 5 and 3? 15, right? 15. 5 will divide evenly into 15, and 3 will divide evenly into 15. Okay? So if I want to use the subtraction method, right? If I want to use the subtraction method, right, to get rid of the y terms, I'm going to get 1 to 15 and 1 to 15, or 1 to negative 15, 1 to negative 15. I want them the same, right? But if I want to add, I want one of them opposite. So 1 negative 15, 1 positive 15. All right. So I'm going to get rid of the x's, all right? And I'm going to use addition, right? So I want one of them to be negative 21 and one of them to be positive 21. All right, so I've decided I'm going to go ahead and make this x term negative 21, the top, okay? Which means if I want this to be negative 21, I'm going to multiply by negative 3. Negative 3 times 7 is negative 21. So I'm going to multiply the top equation by negative 3. And likewise, if I want the bottom equation, I'm going to want the bottom equation to have an x term that's positive 21, right? Negative 21 on top, positive 21 on the bottom. So I'm going to multiply this by 7. 7 times 3 is 21. So then I'm going to multiply the bottom by 7. Okay, most common mistake is that we forget to multiply this constant on the right-hand side, okay, by a multiplier here. We're trying to multiply by negative 3. We forget to multiply the negative 2. Same thing with the 7 here. Okay, so let's make sure that we don't make that mistake. So negative 3 times 7x is negative 21x. Negative 3 times negative 5 is positive 15y. And negative 3 times negative 2 is positive 6. All right, let's go ahead and take care of this bottom equation. We're going to multiply it by 7 to get that positive 21. There's 21x. See, we have the negative 21x and the 21x. That's exactly what we want. 7 times negative 3 is negative 21y, and 7 times 7 is 49. All right, so I'm going to go ahead and highlight. Here's our modified equation. And our second modified equation, you see we've accomplished our goal of having opposites. So unlike the previous equation, we had to modify both equations to get them in a form, right, where we can eliminate a variable. All right, so I'm gonna rewrite these. Okay, I'm gonna rewrite these below. All right, so I'm gonna rewrite these over here. We got 21x plus 15y equals 6, and then we have 21x I'm copying this equation here. Minus 21y equals 49. Okay. And I'm going to use the addition method to eliminate. All right. Okay, now let's get back to this. We have to understand what we're trying to find again. It's important. We get caught up in the steps so many times and trying to eliminate x's and y's. What are we trying to find? We're trying to find the x and y value, okay, that ordered pair, that will make both statements true. That means if I plugged in the x value and the y value, x value and y value, in the top equation it's going to give me -2, and the bottom equation is going to give me 7, all right? And if it does, if we find an ordered pair, that's true. It works for the top and the bottom, makes a true statement. That is our solution. It's got to work for both. All right. What does that mean if we graph these two lines? That means where they intersect. Okay. What x and y value is where they intersect, is the location of where these two lines intersect. All right. So when we add these two equations, you can see it's going to eliminate our x's. We're going to have 0 x's. And then we have 15y positive plus -21, which when I combine those gives me -6. 15y plus -21y is -6y. Now I'm going to add 6 with 49, which gives me 54. And our final step is to divide by -6. Okay, and a positive divided by a negative is negative, and 6 divides into 54 9 times. So our y value is -9. Okay, so the intersection point, okay, of these two lines is at something -9. Okay, the y value is -9. All right, let's find the x value. And as you guys know, we're going to take one of our equations. And here's the thing. We have 4 equations to choose from. We have the original 2, but these 2 equations we modified, right? The 2 equations that we came up with, all right, when we multiplied this one by -3 and this one by 7, we have 2 additional equations. We could plug into any one of these 4. This, 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 and this. I think visually the easiest one to plug into is this second one, but you can plug into any 4. So we're going to take 3x minus 3y equals 7. Okay, I'm going to take 3x minus 3y equals 7, and I'm going to replace the x value. I'm sorry, the y value. I'm going to replace the y value with -9. So this is what it looks like. -3 times -9 equals 7. Okay. -3 times -9.
Carlos Jarrell, please come to the office. Carlos Jarrell, please come to the office.
So we're going to take -3 times -9, multiply that, we get positive 27. When I isolate the x here, I'm going to subtract that 27 from both sides. And 7 minus 27 is -20. Right, we're going to subtract that 27, right? -20. And then we're going to divide both sides by -3. And you guys can see these are not compatible. So 3 will not divide evenly. Negative divided by positive, negative. We can actually leave this as -23. But we might opt to write it as a mixed number. How many times does 3 divide into 20 evenly? 6, right? 3 times 6 is 20. Sorry, 3 times 6 is 18, which leaves us 2/3. And so that's our intersection point. Once again, can you imagine if we actually graph this? These two lines would intersect at -6 2/3 and -9, but we actually be able to calculate that. Would we actually be able to look at that intersection point and go, yeah, you know what? That looks like -6 2/3 and -9. Probably not. And so it's important that we have another mathematical strategy that can exactly calculate that point. Graphing is a great checking method. It's not always a great method to find the exact location. Okay. So I hope this was helpful.